This is Saranya Sheshalna. Welcome to Easy BTech. Today in this class we are going to learn about another important routing algorithm is distance vector routing algorithm. Distance vector routing algorithm. Let us get into the topic. What is the purpose and what is the procedure of this routing algorithm? How can we simplify the routing process here? Right? Okay. Distance vector routing algorithm. See, before going to the distance vector routing algorithm, it is a dynamic routing algorithm. Dynamic routing algorithm. It is an example of dynamic routing algorithm. See, dynamic routing algorithm means it is used to implement the larger type of networks. It is used to implement the larger type of networks, and it is also called as an unicasting. Unicasting. Actually, we have a three types of algorithms, three types of procedures: unicasting, broadcasting, multicasting. Unicasting, broadcasting, multicasting. See, in the unicasting, we have to send the data or we can transmit the data, we can communicate data from one source to one destination. One to one communication is possible in unicasting. Broadcasting, it is an one to many. One to many means we already discussed in the previous video while we are communicating data from source to destination where the other nodes will connect to that particular network, the other nodes also will receive this data packet. That is one to many. While coming to the multicasting means this is also one to many, but there is a difference between broadcasting and multicasting means here one source to different destinations, one source to different destinations, so multiple destinations. Broadcasting is not like that. While we are communicating from one source to one destination in the network, which are the other devices that connected to the particular network, that devices are not an destinations here, just just intermediate nodes. While communicating from source to destination, these are the intermediate nodes that's only connected to that particular network. So but that nodes also will receive this data packet. That is in broadcasting. In multicasting, so we have a multiple number of destinations, right? Multiple number of destinations, like in client and server communication. Imagine client and server communication. We have one server and different type of clients. So the particular data will be distributed to different clients, like that. That is coming to the multicasting. See, this distance vector routing algorithm is comes under the unicasting one-to-one communication. One-to-one communication. Right. Let us see what is the procedure have in this distance vector routing algorithm. Mainly, the distance vector routing algorithm the follow the main three things. The first one, iterative, distributed, asynchronous. Iterative, distributed, and asynchronous. So, iterative process means it is a continuous process of communication in the network until the source and destination will never exchange the data. This process will be continuous. The exchange of data process will be continued until there is no data to communicate from source and destination. Right? This is an iterative process. So this will be supported by a distance vector routing algorithm. And next, distributed. Distributed means in this each and every node receives information from one or more of its directly attached neighbors. Here, each and every node receives information from one or more of its directly attached to neighbors. Here means in a particular network, the one system will be connected to number of systems, right? So here what are the information get by this by that network? This information will all be distributed to the corresponding neighbors means which directly connected to that particular systems. That is undistributed. Asynchronous. Asynchronous means there is no simultaneous communication. Simultaneous means at a time we can send the data. Okay, here only one after another. One after another means asynchronous. While communicating data from source to destination, this process will be completed, then only next process will be established. Means next process will be generated. Right. So simultaneous or synchronous communication is not possible in this. Only one-to-one communication. Right. See, already I said this is a dynamic algorithm. It is used for a larger type of networks. And the distance vector routing algorithm is mainly used in ARPANET and RIP. ARPANET we already discussed in the previous classes what is meant by ARPANET and what is the internet. So RIP means routing information protocol. Routing information protocol. So mainly this routing algorithm we used in this type of networks, ARPANET and routing information protocol. Here each and every router maintains an routing vector table. Routing vector table means this particular node will connect it to different type of nodes, right, in the network, different type of nodes. So here each and every node maintains the next neighbor, means where it will be connected to the next node. That information also will be stored in this particular node. Each and every node maintain an distance table or routing table of vector, next node. Right. So these are the procedures will be go on this distance vector routing algorithm. Right. So let us take an one example how we use a distance vector routing algorithm in a particular network. Okay, so let us see in one example. Okay, let us see the example. Distance vector routing algorithm, right? Okay, I already said this is an unicasting, means one-to-one communication, as well as it is example of dynamic routing algorithm. Dynamic routing algorithm. Okay. Okay, so before consider one example, here we have to remember one point. We have to remember one point. That means this distance vector routing algorithm, distance vector, remember this point carefully, routing algorithm okay, is used to to simplify simplify routing process to simplify routing process by assuming the cost by assuming the cost link of particular node. Okay, assuming the cost link of a particular node. Cost means it mainly simplifies the routing process by using on cost. Here in this particular distance vector routing algorithm, we just I'm drawing on one example. So I take an 3 nodes here. Okay, so this is an A to B distance. Here I put an 1 cost, 3, 4. Okay, so it mainly simplify the routing. So this is a source and this is a destination, right? Okay, whenever we are sending the data from source to destination, it mainly simplifies the by assuming the cost. Cost means minimum distance or minimum cost. Here A to C we have a cost 3 and we can also go for another route A to B, B to C. Okay, so 2 plus 4 is equal to 6, 3. So where is the minimum cost? Minimum cost, this is the minimum distance. Cost means the minimum distance between source and destination. It takes that cost link of the particular node and it will simplify by using that cost link, simplify the routing process by using that cost link in the network. So let us take one type of network. Okay, one type of network. So let us consider one example. Let us consider one example. Okay, so I take and one network here. Okay, this is one type of network I taken. Okay, so here the main important point of distance vector, I already said each and every node maintain an routing table or distance table of vector, means consider. So here each and every node maintain a distance vector table or routing table. Distance vector table. So each and every node in a particular network, it maintains a distance vector table. Okay, so it's simply in this table, this node connected to the two nodes B and C. Okay, so this particular information will be stored in this table. So which is the minimum cost? Where is the minimum cost? Where are the intermediate nodes? Where it will be linked? Okay, what are the neighbor nodes? The neighbor nodes, that information will be stored in each and every node. Okay. Okay, so let us take one source and one destination here in this particular network. How the distance vector table will be create and will be update. Here the particular routing table will be create and table and updating and table. Two possibilities is there. First we have to create an table. Okay, create an table and next we will update that particular table by sending an information or data from source to destination, right? Okay, so this is a network, right? In the previous thing I didn't give an minimum cost. In this I will give an cost for each and every link. Okay, so 3 2 1 5 6 4 9. So these are the cost of each and every link. Okay, I am assuming A is an source and D is an destination. So for A I am creating an distance vector table. So in this distance vector table we have a three parts. The first part indicates the destination, or we can say this is a network ID or net ID. And the second part indicates the cost. So which is the minimum distance cost. Okay, the third part indicates an intermediate router. So while sending data from source to destination, in between there are many routers will be there or many nodes will be there. So that will be intermediate nodes. Okay, so this vector table will be divided into three parts: network ID, cost, and intermediate node. Okay, so we have to calculate the minimum distance to transfer data from source to destination, right? That is the main thing. Okay, here there is one type of formula we have in distance vector routing table. One type of formula to find a minimum cost, or a minimum distance from source to destination. That is, okay. Okay. So this is an formula. Here X is a source, Y is an destination. X is a source, Y is an destination, and this D indicates a distance. Okay, so distance of source and destination we have to calculate, right? So the minimum V stands for vector, means intermediate node. So this is an source and this is an intermediate node. Right? Okay. Next, this is an destination. Okay, destination. See, we have to find the minimum cost or the minimum distance between source and a destination, the which intermediate nodes will be an also less. The intermediate nodes will also be an less format. Okay, find out the minimum cost. Let us find out the minimum cost. I am writing this particular network again. A, B, C, D, E. Okay, so here we have to write an minimum cost. In the previous what we wrote 3 for this. A to D we have 2 and this is 1 and this is 5, 4, okay, 6 and this is 9, I think so. Okay, so we have to calculate the minimum distance. First of all, I am assuming A is an source and D is an destination. Okay, I want to find the minimum cost. So I am writing an distance vector table here for A. A's vector table. Okay, this is an destination or network ID we can call, and minimum cost, and next hope is the intermediate nodes or the mediator nodes. So we have to find the roots. First of all, find the roots from A. Okay, A to D, one root. The minimum cost is 2. Next, A to B to D. We are finding the roots 4. 3 plus 1, 4. Next, in this also we have one root. A to B to A to B to C to F to E to D. Right? Okay. So we have to calculate this. 3 plus 5 plus 9 plus 4 plus 6. Calculate this. 3, 9, 17, 17 plus 4, 21, 27. In this particular type of roots, we have to take an least cost or the minimum cost. In this, minimum cost is A to D. So update information So I am creating here vector table and I am updating here information. So destination is D, the cost is 2, next to hope. The direct there is in between A to D there is no intermediate nodes. I have there is no intermediate nodes in between A to D. So the next hope is also D. Right. So like that we can create this type of vector table for each and every node. For each and every node by using this type of we can also substitute in formula also, or we can analyze this type of whenever there is one complexity will be there, whenever the particular three we are finding an 3 or 4 roots, right? Okay, in this each and every node has the same cost. Each and every node has the same cost, nothing but a 9 or 11. 3 rows will come and same cost means here we have to find the minimum number of nodes. Minimum number of nodes. In which root we have a minimum number of nodes, this will be taken as the least cost. That will be taken as the least cost. Like that we have to calculate the minimum route or the best route from source to destination by using this distance vector table, and each and every node maintains this table and update this table also. We can take A as a source, B as a source, C as a source, and E, F also source. We can communicate this type of information from one node to another node. Okay, at a time only one-to-one communication is possible. Asynchronous communication, there is no possibility of the synchronous communication, right? Okay, let us see the what are the advantages of this vector table. I only show then one type of example. We can take a number of B as a source or D as a destination, or B as a source, E as a destination. We can take any type of nodes, right? We have to maintain that vector table for each and every node to find the minimum cost, right? Okay, so let us see the advantages. Distance vector routing is, so it is easy to implement in smaller networks because this is a very efficient algorithm. It's mainly useful for an larger network. Why means dynamic routing algorithm means we can instantly extend our network. We can instantly extend our network, but there is some disadvantage. This distance vector routing algorithm, while we are extending our network, the routers will also increase, and this vector table will also be increased. So the communication gap, the communication is not um, correctly transferred between source and destination. There is a problem of communication between source and destination, or source and other nodes also. So for smaller type of networks it is very well suitable, but we are not using in a smaller type of networks. The distance vector routing will be used for an larger type of networks, and while we are using in smaller type of networks, so the debugging also very easy. Okay, that is an advantages, and this is also has a very limited redundancy in small network. These are the advantages. Disadvantages means mainly we are using this larger type of network. This distance vector routing is mainly used for a larger type of networks. There is a when for somewhat it will be good whenever we extend this network into larger thing. It is very difficult for communication, right? There is a problem rise in communication. I hope you understand this distance vector routing algorithm. Kindly like, share, subscribe EasyBTech for more videos. Thank you.